Welcome everyone. I'm really happy to be here with my friend Rodrigo to talk to you about how to reinforce your security foundation and design to be trust. My name is Natalia Vinto. I'm a technical director here in Red Hat. I work in the OpenShift BU, and I'm here with my friend and colleague Rodrigo. How are you?
Oh, good, man. How about yourself?
Good, good. Excited to do this session with you.
Oh, yes, I am.
All right, let's go. We want to talk to you about something you know already. So why does security matter? We want to reinforce the idea, and then we will show what Red Hat is doing in this space and what we're doing in the secure software supply chain in the security space. And then we'll show you a demo on how everything is connected with our products with an example application DevSecOps pipeline. But first of all, why does security matter? We know that cyber threats are becoming more sophisticated and frequent. Moreover, in this AI era, no, there are more attack vector, more things to be care, and security is no longer just the responsibility of one single team. We know that usually security team was the one in charge of the security overall, but today developers can take care of their dependencies. DevOps can take care about the container image, the Docker file, the container image, and so on. So it's a network as well, can be taken care about the network security. So it's a shared responsibility. And proactive security builds trust and resiliency. And more these days, when attacks are increasing at a crazy speed, we need some proactive approach in this part. And here's the challenge. How do we balance security with innovation? How do we make sure that developers can, self-serve, can deploy application, can order the database they need, they can consume their stream they need, their models they need, by putting also security, making sure that everything it's inside the route, the right boundaries. We believe that platform engineering could be the answer for that, because platform engineering is a methodology, is a practice, and the platform engineers today play a key role in offering a standardized platform. Where we observed, in the recent past, a shift from things like platform as a service to another concept called platform as a product. And so the platform engineers and platform engineers will provide developer security guardrails to create software, some resilient software at scale. So they can self-serve, but with security guardrails. So in order to implement automated deployment, but also automated security policies, like we will see later in the demo for compliance and regulatory. So that's very important. And the other topic I want to talk to you about, it's that security should be added by design. I like this slide. It really shows, the traditional security approach with manual code review, firewalls and perimeter security, checksum verification, or private artifacts repository. And when you move to the modern security option that we have today, we have the software bill of materials. This file that has a visibility into all the components, all the dependency of your apps, and then some automation around signing and verification. Provenance and attestation will show also in the demo later with immutable ledger. And frameworks, standards. Now, there's this new framework called SALSA framework for secure software builds pipeline with provenance guarantees, and also dependency scanning, reproducible builds, and moreover, runtime protection. We'll see also in the demo specifically how policies can be deployed in any phases, but also moreover deployed at runtime to prevent attack also when the application is already there. But this supply chain security space is relatively young, because actually the DevSecOps movement have more than decades. I remember the DevSecOps movement, Rodrigo, I don't know if you remember it. It was more than 10 years ago. And it's that, of course, from DevOps. So putting security around DevOps methodology. And the supply chain security now it's young because it started as a standalone movement or community, if you will. And also the thing that there's fulfilling this space is also about regulation that come often, government regulation. No, we hear more and more regulation, a government that dictate what is the good way to provide software to the public administration on how things need to be done in some countries or region or whatever. And so it's a relatively young space with decades of experience. But in any case, software security is a journey. We really start from basic security, and then we go to the upper level of the evolution of security. And if you think about what are the domains of software security, we believe there are at least 4 domains relevant. One is software composition, how your software is composed. Is your software having some dependencies that is not allowed, or it's violating any licenses? And then what about scanning? There's a need to scan, assess the composition of software for potential vulnerabilities, scanning the software, scanning the dependency, signing the commits, signing the artifact, signing the container image, signing either the pipelines. And then policy management and enforcement. So you can define and enforce condition for software to assess the asset that might comply in order to be used. So those are the domain. And I think we have 3 major pillars. I'll explain and show that with an opinionated view from Red Hat. But the 3 pillars are valid topics for everyone. And also those are agnostic concepts. First of all, you need to prevent and identify malicious code, then safeguard build system early, and then continuously monitor security at runtime, which is one of the most important. So let's start from the first one, prevent and identify malicious code. Here's an opinionated pipeline, right? But the concepts are valid always. And you start, from your code base, and your application will use a set of application libraries, language runtime. If it's using container image, also, some base image. So you need provenance and attestation for curated content. And when you start, and there are some open source software that help you with that, and also some products that Red Hat is building around the space. One of these is the Red Hat Trusted Profile Analyzer, for instance. And let's go into the code phase. No, when you work with some code, we heard that it's important to do a software composition analysis. Okay, this is my app. Here's the composition of my app with all the dependencies. And so you can have a dependency analysis with recommendation. The open source software around that, there are many in the space, but the one that Red Hat selected to be also productized are SigStore, and we're working with in browser IDE like EclipseJet that we productize in a product called OpenShift Dev Spaces. And then the product around the signing of the code is Trusted Artifact Signer based on SigStore. And the product around the dependency analysis recommendation, the bomb file management, is the Trusted Profile Analyzer. So this is the first phase. Let's go into the second phase about to safeguard build system early. And this is around the CI part. And for the CI part, you need to build. First of all, you need to build the software. Now you build the artifact. Then you need to sign the artifact. You might need to sign the artifact. You might need to build the container image, sign the container image, scan the container image, and then provide SASA attestation software bill of material. So you're building an artifact or a container image for a certain environment, and then you have your software bill of material deployed into the pipeline. The pipeline is going to produce that. It's gonna store that in some places, and one of these places could be Trusted Profile Analyzer, and the product that can do this digital signature or artifact container image for us is Trusted Artifact Signer, which is again based on SigStore. For scanning, we're using Red Hat Quay. which is based on the open source software called Claire, and it's connected to advanced cluster security for Kubernetes that we will see in action in a moment. But from a pipeline perspective, also out of the box, OpenShift pipeline brings on the table SASA level 3 compliance for attestation provenance thanks to Tecton and Tecton chains. Tecton chains is an add-on for Tecton, it's Kubernetes native pipeline system that can provide digital signature also for the running of the pipeline. So you are preventing an attack also on the CI part, and it becomes more difficult, attacking and injecting malicious code at pipeline side in the pipeline side. So this is the CI part. What about the CD part for deployment? You can deploy the app in many ways, right? But we believe GitOps is today one of the standard to deploy application, GitOps approach. So for us is OpenShift GitOps. It's based on Argo CD, and then you can use a product like Advanced Cluster Security for Kubernetes, which is based on the upstream project StackRox, and you can use those StackRox policies to ensure and enforce policies. Of course, you can use other policy agent like Open Policy Agent, but in the deployment phase, this is where you're gonna do signature check before the deployment. You're gonna check if what you're producing is valid for a certain environment. That's why we have this other open source project called Conforma, which is part of the family of Trusted Profile Analyzer. And then you can see that this project can validate a deployment, validate the SASA compliancy of the deployment in a certain environment. And Advanced Cluster Security for Kubernetes will do some check and policy and for the policy at the deploy side. Again, you can do a build side in the build phase, deploy phase, runtime phase. We'll see that in action, but it's important to have that to keep that in mind. And last but not least, continuous monitoring for security at runtime. In this space, from a Red Hat perspective, it's always about advanced cluster security for Kubernetes, and also you have observability. So observability tool, you can use, Prometheus, and you can take benefit of OpenShift observability stack. It's important here to also do some network observability and Kubernetes native security built in, and ACS, Advanced Cluster Security Policy, allow you to do this monitoring in action. I want to show you what is this the package for software supply chain. So for that trusted software supply chain is a composition of various bundle that I was showing to you. So on top of OpenShift and Quay, Advanced Cluster Security for Kubernetes, you have our Advanced Developer Suite that contains Developer Hub, Trusted Artifact Signer, and Trusted Profile Analyzer. And we have talked about some products and projects, but we believe that we really believe security begins with the community. And open source security is built upon thriving open source community, and the community for security, it is thriving. It is striving for AI. It is striving for security. That's the truth. You can see in all the conferences how many events, how many talk are around security. But what are customers like you interested in? What are the common patterns? By talking with customers, by working with them, we understood the common pattern that interest customers and businesses are this: image vulnerability, of course, understanding composition of software content and any vulnerability, content signing, it becoming more relevant, applying digital signature in many steps, as we discussed, and policy enforcement. This is one of the most important, forbidding the use of software that does not meet the final compliance level. Example, this their image, it's not signed, cannot go to production. Or that, just to give you an example, Rodrigo will show a demo around those policies. But before we continue, I don't know if you're familiar with all those acronyms I'm using, the SALSA, supply chain level for software Actify. It's a standard. Here's some terminology where you might hear a lot about CVE, common vulnerability exposure. Moreover, this day you hear a lot about this CVE. Provenance and attestation. So provenance is a record of origin, history, and who made the change. And attestation is an authenticated statement in the metadata about the software architect or a collection of software architect. And software bill of material is, again, this file that represents the composition, software dependent composition with all the dependencies for your application from the programming language, but also from the container image if you're using container images. And here's the salsa level. So salsa level 3, I was mentioning before, a Tecton chain is implementing salsa level 3. So it is OpenShift pipeline with Tecton chains. But there's different security level. The level 0 is dry run security, and then you go up to the level 3, which is the most interesting, preventing tampering during the build. And preventing runs from influencing one another. It's really important in the CI/CD context to have level 3 compliance. Tecton chain has already, others are coming, but I just wanted to highlight this. And this is all in the approach. What is the approach? The right approach is to shift left security, right? You can see a diagram that explains it very, very well. And today, approach of shift left, shift down. Security, and here's our kind of opinionated pipeline for that. And also open source project community we're involved in, and you have also the opportunity to influence the future by joining those community, and we're very keen to help you join in the community and help us contribute to this community. But what defines a software delivery process? Again, OpenShift pipelines, but you might be interested in GitHub Action, GitLab, Azure DevOps, Jenkins Tech, and others. For all of this, it's important to have those pillars like the signing of the content, what to sign, how to sign, where to sign, and for about what to sign, again, we were mentioning you can sign commits, you can sign artifacts, you can sign container images, so you can sign any binaries. This is what you usually sign in your typically in your CI pipeline. And how do you sign it? Where you can have multiple way to do digital signature, but you can have self-managed. So you can use the cosign CLI if you're using SigStore, Trusted Artifact Signer, or you can use a key management system like HashiCorp Vault to manage the signature, or either you can have hardware token. There's also a keyless signing approach on this that we're bringing a Trusted Artifact Signer, so you can sign using generating a short-lived key pair against an identity using an OIDC. In the demo, we'll show this for instance, with Keycloak, Red Hat SSO. So you can use Keycloak to do this this keyless signing. You just authenticate in OpenShift and using Keycloak, and then that digital signature applies in a keyless fashion. And he's using this sub project from SigStore. It's called Fulcio. Just want to highlight again that the pipeline support, for those of you that want to use OpenShift pipeline, use OpenShift pipeline. You can sign the images. Hey, you can sign the pipelines again. So there's a digital signature also in the pipeline. That's the beauty of having SASA level 3 compliance for Tecton chains. And if we want to recap, what are the key pillars of secure software development lifecycle? First of all, if you want to, the key takeaways from this session today, in my opinion, are, SBOM. Those are foundation for transparency and dependency. So dependency management, really take care of what your hello world, or you don't have hello world, of course, right? You have a business critical app, but the business critical app is some amount of line of code, and then there's lots of dependencies. And you have to reduce the vulnerability for those third-party components. How you do that? You track them, you scan them. And just so you apply DevSecOps practices. You are shifting security left, starting from the code. And you ensure software integrity and signature and attestation backed by a transparency log. Then, I think you like it. Policy as a code, everything as a code, infrastructure as a code, network as a code, policy as a code. Your StackRox policy, your advanced cluster security for Kubernetes policies can be tracked on Git. So you can use GitOps and then you can apply this with an automation. You make a code revision, code for also for your policy and the security policy automation again, in order to do continuous enforcement, continuous governance, and continuous compliance. So here's the classic word, no? Software development lifecycle. You have your app, you have your CI/CD pipeline for coding, build, deploy, monitor. You will see that. What about the AI part? You might have your model. So you have your data science pipeline, no? The data preparation, train the model, deploy the model, monitor the model. How do you put security in this space? Well, you can do the same. You can apply the same concept. You do software integrity in the data preparation, the code side. You do a risk profile management when you train the model, when you manage the model, right? And then you do continuous monitoring when you deploy the app or monitoring and deploy the models. This is how you could do also for AI. And if you look the bottom arrow, this goes on the left in the model transparency, on the right in adversarial attack and manipulation. So it's all the phases have the different contexts, but important is that you can fully own also this part. And with AI specifically, we have new workload risk because there might be something like just a prompt injection, or either training is not the training data source are not public available. You don't know the training data set. Actually, it can be just a license violation, right? So you need to start defending from malicious actor and adversaries, and that's why again signing, verification, provenance, attestation, model validation is really important, and create the so-called risk profile, a vulnerability, license, trusted model. You can start from a trusted model that will ensure the liability, ensure the so-called indemnity, right? And this is valid also for the vulnerability. And for a safety perspective, again, what is the safety of a model? The model shouldn't cause unintentional harm, like you might check about correctness, bias, fairness, preventing prompt injection, manipulation, poisoning, and then you'll see this more and more, guardrails and shield, guardrails and safety. This is how you manage this work. And how this can help you, the secure supply chain for models. You can have some AI safety metrics, so you can evaluate if the model is good or not in terms of some metrics. You see this toxicity, bias, trustful QA, and so on. There are some metrics that you can use. And then you can see the score. So you put this in your pipeline, in your review, in your reporting, and again, add always output shield guardrails to verify that what it comes out from the model, it's okay. And the framework we have in Red Hat AI also help you ensuring that. So today we focus on this particular stack. Is the OpenShift OPP stack, and we've advanced the OpenShift Platform Plus stack is OpenShift Platform Plus with advanced class security for Kubernetes, but also with advanced developer suite. So how do you put this secure supply chain? How do you put developer productivity in action in a secure way? And in particular for advanced developer suite, this is the product suite that we offer. You see some of those in the demo. You might in the discussion beforehand. You have trusted software supply chains, which is a trusted artifact signer, a trusted profile analyzer. Then you have a developer app as an internal developer portal and platform. And then you have also migration toolkits. You have also Podman Desktop for secure containers workload run at for local development, but also for local model inference and serving. And I wanna, before we go into the demos and before we go into the deep dive in the advanced cluster security, I want to show you the generic CI/CD pipeline, generic development process. You have the code, dependencies, base image. Then you build the pipeline. Then you have the deployment. In some way, you do the deployment, and then you do the deploy in some more environment. You start monitoring. And here's a security augmented development process. And what I like from here, that this is showing you how all those pieces comes together. So from the code side, you have a trusted Red Hat Trusted Profile Analyzer with Red Hat Dependency Analytics that can scan your code before you send to the pipeline. So analyze, create this software composition again and scanning it. And then you can digitally sign your commits so that with trusted Red Hat Trusted Artifact Signer, so that DevSecOps pipeline can have one gate that is verifying is the commit is signed by you, the developer, you, the user, right? If it's okay, then it can go into the other gates, classic gates, but security enhanced gate are for sure signature and scan of container image and generation of bomb file software bill of material. And you see here there are many components involved. You push the registry, you put the container image to the registry for scan and for storage, but also for scanning. And then advanced class security for Kubernetes can act at the build phase, can act at the deploy phase. You can deploy this with GitOps in one or more environment. You can verify SASA compliance with Conforma before you send it to the environment. So this is the opinionated pipeline, which could be also digitally signed itself again. All right, and this is the security augmented pipeline that we discussed, and I want to show that in action. That's why we prepared a little demo. We will show this DevSecOps pipeline with all the security gates in action, and then Rodrigo is going to take over and show how advanced class of security for Kubernetes can be used in your DevSecOps pipeline, and also showing some advanced feature you can do for policy enforcement at runtime. But let me go to the demo. First of all, I want to show this. I want to show developer app. This is part of advanced developer suite for it's part of advanced developer suite. And it's it is an internal developer portal that you can use to scaffold new applications. So your developer will be onboarded in this software catalog where you can see all their apps running, the apps that they own. There's Airbag, there's multi-tenancy, and so on. What I like from developer app is self-service with guardrails. So as a developer here, I'm user one, and you can see all the software template for any programming language that I have to use. And one of this is this one, like securing Java Quarkus service with Quarkus. So as a developer, I can go here and I can say, this is my application, this is my package, this is my registry. I can use this registry because somebody already configured for me, the platform engineers, as we discussed. And this is my repo. Do I want to enable yes or no verification of commit? Let's say, yeah, I want to enable those. And when I click create here, what happens under the hood, there's an automation that will scaffold the skeleton of this project. So the right base image, the right dependencies, the right pipeline I should use, the right deployment, all the security gates, and all we discussed beforehand. It's all here. And this is the overview in developer app. And this is the, we just created this application. So there's an automation that will create all the pipeline and so on. So to save time, we already created the same example. I just call it in another way, no? And I want to show you that from scratch, what I have here, first of all, I have my development environment. When I click here, this is going to open a dev spaces, which is this in-browser IDE that can automate all the development environment. And when you use that, essentially this will create what you need. In this case, I need Java. I need my run configuration. I need some extension like the dependency analytics we were discussing beforehand. So long story short, when this start it's up and running, you'll see something like this. In this case, it's Visual Studio Code, but you can use also IntelliJ. What I like from here, this is my application skeleton. This is all the dependency. Let's say company approved dependency. And here's my base image. It's let's say company proof base image in this case. But I want to show you this. As a developer, let's imagine we want to do some change. And before we do this change, we can scan these dependencies beforehand. So all the dependencies that we have here, we can perform a so-called scan with dependency analytics. And it's totally dependent analytics. It's really simple. It's just an extension. In this case, we fully automated the extension, but it's a matter in dev spaces or any IDE you like. Just go here and you look for dependency analytics. And here we are. It's in the marketplace. You install it and you have this local scanning. So let's imagine I want to scan this before sending something. And for the sake of the demo, let's just as a cool let's do this small change, right? Small change in the documentation. But let's perform a security scan before we send this to the pipeline. I already sent the scan in order to save time. I just want to show you that, this project has already some vulnerability. Am I okay with this vulnerability? It looks like there's no critical vulnerability, just important vulnerability. But here's where the vulnerability comes from. So the tool is telling me, you know what, you're not versioning your dependency here. So that's why here you're inheriting some default version. And this default version has some high vulnerability. This comes from the dependency file, Java, Go, Python, there are many programming languages supported. But here I have the full overview. And also, the license summary. For all my dependency, am I using all the right licenses? Those are permissive, but you know what? There are weak copy left and unknown. What is the dependencies of this unknown here? It's something that I might need to check out. And I can do that. For the vulnerability, I can go here and I can see I have one direct vulnerability. This is the CVE, and I can go ahead and try to fix that. Maybe I can improve the version of this application. But for the licenses, for instance, I can go here and can see what is the unknown. First, this one is unknown. Is it okay for me? Yes or no? Let's imagine for some reason we're okay with important vulnerability. Let's push this. I want to show you this. First of all, we can add our file that we will change it. Just this readme. We'll do like commit. Just update. Now, what is happening? We're digitally signing this commit. From this dev spaces, we're doing with kicklock by sharing a code between the IDE and the web interface. So here we just digitally signed this commit. From our IDE locally, we don't have to do this copy paste. It's gonna open a web page in localhost, and we will just do the signing. But we did the same. We were using kicklock to do this signing, and finally we can push this. What happens when you push the code? When you push the code, and again, we were okay with this high vulnerability for some reason. But when you there's an automation in all of this that's come from the software template, and this automation is showing a new pipeline starting right now, and this pipeline is going to all the security gates, which is a verification of digital signature of the commit, test unitary test, building and signing the container image, generation of software bill of material, advanced class security image policy check, scanning, and so on. And then finally, showing the software bill of material and deploying the application with GitOps. So this software template has the DevSecOps part, as the CD part. I'm using, our OpenShift GitOps to deploy in the pipeline itself, the development environment, product environment, stage environment, and so on. I want to show you three things. First of all, this other pipeline I was running some minutes ago, it's already run. I just want to show that as a developer, I don't need to access the cluster of the pipeline system. I can get the logs from here. So that's one good thing. And here's the verification step. I'm verifying that it's just user one on GitLab that is signing this commit. Is it okay? Yes. So this pipeline can go. I was trying to do the same with another user, and you know what? The pipeline failed beforehand because only user one is allowed to do this commit here. And in that case, it was not the right user, so the pipeline stopped. That one another security gate. And when the pipeline finished, you can see here that it goes into all the security gate. But look at this: the pipeline is digitally signed. The container image is digitally signed. So when you push this container image over here, all the security scanning Red Hat Quay, but also you see this signed with cosign. All those images that we're pushing, like this one, is signed with the cosign. In this case, we're also pushing this BOM file as a container, but we also push uploading in the trusted profile analyzer to be analyzed. And let me go back to the pipeline. This is the view on the developer app, which is as an integration of OpenShift pipeline. But if you go to OpenShift pipeline, you see the same. You see the signing of the container image, the scanning. So this is the one in progress right now. And you can see all the logs from here. It's just to show you there's an evidence from developer app to the cluster, which is running in this case here. And the other cool thing I want to show you is also that the app at the end will run and will be deployed on OpenShift in one namespace. And when you want to do let's say a promotion of environment, like in the stage environment, like in the prod environment, it will in this case it's architected to be like with tag and release, but you can do in many way. And before sending to the other environment, you run a conforma, so that will verify if the environment is SALSA level 3 compliant, if the Git repo is the one that you need. Another layer of security. As a developer, I don't access the cluster, but I can see the logs of the app if anything is wrong. You see here, there's an exception. I may want to check what's going on here, and I can work on that and see if I can remediate with another Git push. So I really like this. And what I also like, and let me go back to the pipeline, is the integration with trusted profile analyzer for the BOM file. Let me go back here because I want to show you this. See, this is a very complete DevSecOps pipeline. And here's when you upload this BOM file, and this BOM file is uploaded here to Trusted Profile Analyzer. So Trusted Profile Analyzer will analyze this BOM file, like this one we just uploaded. You see there are more vulnerability compared to what we've seen in the pipeline and also what we see in the dependency, because this BOM file is the combination of the dependency and the container image layer. So here you will see a list of package that come from the base image we're using, but also a list of packages that come from the dependency file that we're using for our application. And so the vulnerability of this BOM file, what is important, as you can see, we have two critical vulnerability that we haven't observed neither in the code side, but also in the image side. So it's important to have also the scanning of the dependencies. That's why it's super important. And another thing very important is to check if there's any violation of policies with ICS. I really like the integration of advanced cluster security for Kubernetes, and Rodrigo will show that in action in details. But here we're using RockCTL to check if there's any violation of policy. We don't have any violation so far because we have some important vulnerability, and as a developer I can say, okay, you know what, I have this important vulnerability. I can just fix it by upgrading the base image or upgrading my Quarkus framework that was using an old version, right? But if you see here also on the image check, I'm violating this policy, which is the fixable severity as at least important. I am violating it and it's breaking the build, but it's not enforced. We decided it's not stopping the pipeline, but you can decide to stop the pipeline also because you don't want this important vulnerability at all. And also deployment check. You might violate all the deployment check, like you're not using this, or you're violating Docker CIS. There's a Red Hat package manager in the image. At Red Hat Summit, we announced that our Hummingbird distroless and zero CVE support. No, so you might want to avoid distro-based email. You want to use distroless Hummingbird, like in this way. So there's no package manager. So those are runtime policies, but just I want to give you the heads up that you have the full control of everything here. Yeah, as a developer, you can see everything. Your superpowered Git push, but you are already empowered with many security gates that can mitigate and prevent proactivity vulnerability. And with that, I'd like to pass the control and the word to Rodrigo, because it's going to show advanced class security for Kubernetes in action with more details. Over to you, Rodrigo.
So again, everything starts with a simple idea of building a container, right? But let's just clarify a few things. So a container image, sitting, I would say, in a container registry somewhere, right? It does have a low attack surface, right? So that image is not running, so there's no process to exploit. I would say there's no network to reach, right? So there's no runtime behavior to abuse, right? So the risk at that stage is limited to supply chain, right? So someone could, I don't know, temper the image itself. The problem starts when you run that image somewhere, right? When you deploy that image, and then the attack surface is going to expand, right? So now that running image does have a process or processes, right? It will have I would say, a network identity, a set of permissions, access to other workloads, right? So, but there's some facts to it, right? So you know where the image are coming from, so you sign them, right? So you scan them. So, but that's not enough to close the gap, right? So signing just confirmed the image is the one that we built, right? Scanning tells us what type of vulnerabilities existed during the build time. But what matters from now is like how the image is used and how you deploy that, right? So that matters. So because a vulnerability in the image with no network access, no privileges, right, is not the same as the same vulnerability in a container, which is running as a privileged container or exposed to the internet, right? So the context around of the workload defines, I would say, it's going to help you define what risk means when it comes to Kubernetes, right? So you need, end of the day, to protect the workloads. Let's say, as Natalia already mentioned, on 3 pillars, right? At the build phase, right? So it's where you control what you build. At the deployment time, right? So this is where you protect the platform, right? And of course, runtime. Because I like to say all the time that what's secure today might not be secure tomorrow, right? 0 days and so on. So, I would say the fields are basically dynamic. It's changing every single day. So this is where you can use, for example, ACS to detect and respond to threats, right? This is exactly what ACS, Advanced Class Security, I'm going to keep calling ACS for, I would say, simplification, right? That's what it does. Natalia, please, next slide. So as you can see here, so I broke into 3 main pillars, right? Build, deploy, and runtime, right? So at the build time, ACS is going to help you to analyze images for vulnerabilities, right? Check your application configurations, and it's easily integratable with any CI/CD pipeline out there. I'm going to show you during the demo how simple it is to use RockCTL to integrate your pipeline with ACS policies, right? And then we move to protecting the platform, right? This is the deployment time. So ACS can leverage the admission controllers to enforce policy rules at the cluster door, right? So it's going to check for compliance. It's going to profile the risk. It's going to block whatever should not get in, right? And it is going to keep watching at the runtime as well, right? It's going to watch the workload behaviors, right? Suggest network policies based on real traffic, right? So it's going to detect threats as they happen, right? So, and just a notice, right? This is not 3 different tools, right? It's one single platform. It's one set of decisions, right? So you apply across the entire lifecycle. Again, build, deploy, runtime, right? You define it once, ACS is going to take care of it, right? It's going to take care of all the rest, right? This is the main core idea. So everything I'm going to show you today is going to come back to this, okay? So let's let's just basically cover what's the major use cases. Natalie, please, next slide. And what you see here is basically the 6 major use cases, right? So again, vulnerability management. This is what most of the companies are asking today, right? Risk profiling, compliance, network segmentation, security policy guardrails, right? Is a single policy engine covering the 3 life cycles, which means ACS is going to find, I would say, the all known vulnerabilities in your images, in your nodes, in your OpenShift components, right? In our running containers. So it's going to also give you context to prioritize, right? So not every single issue is equal, as I mentioned. So ACS is going to rank what's most dangerous based on how it's deployed, right? So what that deployment can reach, what type of permission it has, right? So checking against compliances, is just a click of a button. So you can use ACS to check your clusters against standards like CIS, right? NIST, PCI, so you name it, okay? So when it comes to networking, so it will show you basically how your workloads talks to each other inside the cluster, all right? So also it will help you to lock it down. So it's generate network pulse based on real observed traffic, right? And to be honest, one of the features that I like the most on the platform is the single pulse engine covering all the life cycles, right? So this is going to make sure your workloads follow the security best practices, right, before they reach production, right? So just to give in some small examples, right? So running as root, privilege mode, a simple resource, lacking of resource limits, right? So you can use ACS to catch these things earlier and block at deployment time, right? So as I mentioned, so what's secure today might not be secure tomorrow. So ACS will detect anomalous behavior in running containers. So any unexpected processes, right? Shell access, lateral movements. So you name it, right? So ACS will detect and respond. So either killing the pod, reducing the radio blast, right? So alerting the teams, collecting data for forensics. So all of these across every cluster you manage from a single console. Okay. So and basically, during the demo, Natalia, now we should basically flip to the demo, right? So if I can share my screen.
Yeah. I'll stop sharing so you can
Okay.
start sharing.
All right. So I can start from here, right? So again, the installation of VCS is, I would say, is simple. So it's going to take from 10 to 20 minutes. But once you install it, right? So ACS is going to give you full visibility about what you do have running on those clusters. All right. So the main goal is not to cause any outage, right? It will not block anything initially, right? Again, and the main goal it will basically scan everything, check application configuration, vulnerabilities in our images, and once you log in, you're gonna get this nice dashboard, right? Which means from the dashboard you can get full security metrics across all clusters or even selected resources, right? You can drill down into, for example, my production cluster. Instead of seeing everything, I will filter out from a single payment namespace, right? Again, this is also give you about like a view about risk, right? And as you can see on this namespace, I do have like 26 policy violations, right? So I do have 3 active images. So I have deployment at most risk. And as you can see, my visa processor is the risk number 1, right? So I will show you why ACS is telling me that visa processor is the number 1, which I should take care of, right? But something that is really interesting that people tend to lose and to miss is the aging images, right? Again, let me just get our clusters. And you see now I have like 91 images that are aging, right? So from those 76 are older than 90 to 180 days, right? It already tells you a story without drilling down into more details, okay? But this is telling me that someone is not really taking care of the patching of my container images, and then you can just investigate further, all right? But just moving when it comes to container scanning, right? Vulnerability management. So if I open that up, so you see that ACS is scanning user workloads, as you can see here at the top, right? But also we are splitting into platform, right? Platform vulnerabilities, node vulnerabilities, and also in tech preview, you can also scan Red Hat Linux images running on top of OpenShift virtualization, right? I don't have any VM running here as of now, but just to be aware that we do have this feature, so you can enable it and use it, okay? So when it comes to user workloads, you can easily drill down into more details. For example, I want to see anything that lives on my payment namespace, right? So as you can see, critical, unknown, important that are fixable. You can also, expand this and get more information about like what this CVE is about, right? So this is a CVE that was published 7 years ago, but still resides and lives on my environment, right? Once you open that up, you can see that the same CVE can be found in 2 more deployments, right? So Visa processor and MasterCard running on my production cluster on my payment namespace, right? So how basically you can use ACS to find these type of vulnerabilities and fix earlier on the build time, right? Again, I will not run the pipeline here. I'm gonna let my colleague Natalie Vinto to run that later on, but I want to show you underneath how that works, right? So ACS delivers to you this nice CLI called rockctl, and it runs on Mac, Linux, and Windows, right? So you can run on your machine today, okay? So we're gonna open here a simple terminal, right? Because I want to demonstrate the power of rockctl. So instead of typing, I will copy and paste because it's faster, but you can see this is basically what I want to demonstrate, right? So you're gonna call rockctl image scan, and then you're gonna pass the content image. So this is gonna do is basically I will, it's just contacting ACS, the central, right, to scan the image and send me back the metadata, right? And as you can see, there's a bunch of already CVEs in it, which are fixed that I could basically fix straight away, right? But as of now, I'm just scanning, so there's no action, right? So the action would be something else. So, but leveraging the policy capabilities of ACS, which I will demonstrate to you later on how you can enable these type of checks. So you can use also rockctl image check, right? This is basically checking the image against the policies, right? So if I try to build this image today with check the pipeline with this image today, what's going to happen, right? Let me just run it and see. And as you can see, I do have like 3 policy violations, right? And you notice that the first one is enforced, is equal true, right? Which means at the deployment, at the build time, so the pipeline is going to fail, okay? But again, that's just one phase. What about deployment? So if I try to deploy this image right now on my cluster, what is going to happen, right? So instead of just pushing these YAML to my Git repository and wait Argo CD to pop up an error, right? What you can do, you can always use rockctl as well, deployment check, right? And as you can see, I'm checking the YAML definition from my asset cache, right? It should be simple as that. So let's just enter. And as you can see, I'm violating a policy, right? But there's no enforcement whatsoever, right? Which means these image would be allowed to run on my cluster, which of course it would increase the risk, right? So to change that, so let me just explain to you the policy management, as you can see here on my screen. So out of the box, ACS is going to bring to you around 87 policies, right? So you can use as it is. You can modify them, right? You can clone them. I have done some cloning. As you can see, I do have this policy, which I show you during the CLI demo, right? But I want to change. I want to edit this policy. Okay. So you don't have to learn new language, right? So you can just use the web interface to craft any type of policy, right? It's super simple and intuitive, right? Here's the chance where you can write the description of the policy, why you have this policy in first place, right? The rationale behind of that, and also a guidance. If someone face, this policy violation, a blockage, something like that, you can basically guide them how to fix it, right? So again, I cannot change this because there's already some violations in it, but you can expand and understand more about how you can use this policy engine to protect the life cycles, okay? Next, the rules. Again, I will create a new policy in a couple of seconds, but as you can see, everything is graphical, it's drag and drop. But I want to change the actions, right? So as you can see, it's enabled at the build time, right? I'm enforcing and informing at the build time, right? But not at deployment time. And again, you don't have to do anything on the cluster. It's just a matter of enabling the deployment enforcement. Then I click next. So before applying, right? So this is a preview of the violation because I'm enforcing a deployment time. So what can be the effects on my cluster, right? So as you can see, I'm gonna impact blog, asset cache, because I do have some violations already on that case. But anyway, I'm gonna save that anyway, and I will rerun the same command. So now I do expect some enforcement to be true, right? Which means a developer from day one would understand and know if this deployment, if this workload would be able to run my production cluster, just checking proxytl, CLI against the image, right? And the YAML file definition, all right? So as simple as that. Now, moving back to ACS, right? So as I explained to you at the beginning, we have here some deployments that are at risk, right? And the visa processor is the number one. So let's just open it up for you to understand why this guy is the number one on the risk priority, right? So first of all, a bunch of policy violations, right? So you can see Apache struts, right? This is a really old CVE, but still present on my environment. They would log for shell, but there are a few things here that you must pay attention, right? So I do have like some, I would say, environment variables that contain secrets, right? The same image is run as a privilege, right? So I do have some capabilities that should not be in the case, even if I'm not running as a privilege. So this capability would give some admin access to the host, all right, and so on. Again, this is just risk indicators, policy violations, the number of CVEs that are present on that image, service configuration, right? Again, secrets has SSH keys within a deployment. So nobody nowadays should run SSH on a container, right? But here we are. So if someone's exposing port 22 on the container, right? Service reachability. The components that are useful for attackers, right? So usually they are using tools that we are providing them, right? So curl, bash, RPM to installing stuff, and so on, okay? And from that, right, this is what ACS learns from your application. So I demonstrated like, using RxCTL, for example, to verify the image against build time and deployment time. So here from the visa process discovery, right? So ACS will learn the expected behavior from that application from when it comes to processes, right? So on that learning phase, it will learn that, it's just need Java and it's going to spawn a jar file, which is going to probably listen on port 8080 and receive traffic from another application, right? So by default, right, once you install ACS, the outlock is not enabled. You can enable that by default manually, right? Or you can just configure ACS to outlock after the learning phase, okay? But just to demonstrate that how that works, so how ACS can demonstrate at that protection at runtime, I have prepared here some live attacks, right? So I have here some scenarios. So end of the day, what I'm going to do, I will exploit my asset cache, which exposed to the internet, right? Asset cache will move laterally and get access to the visa and extract the token. And the attack goes from that. So, and so far that's working pretty well, right? And as you can see, I was able to extract the token, and the token contains privilege access, okay? So if I try to use this, I can get the pods, I can get the nodes. So basically it's a cluster takeover, right? So, but from a ACS standpoint, how ACS would basically allow you to visualize and block this type of stuff. So if I go back to violations, now you see that ACS has already triggered some violations, right? You can see a shell was spawned by a Java application, right? So if you expand that, you're going to be able to see all the events, right? So someone was able to respond a bash, get the host name, get the token, right? When it occurs, what's the container ID, user ID, and so on. Then basically by getting this type of information, you can start investigating and connecting the dots. All right. So another is the unauthorized network flow, unauthorized network process execution. All right. This everything covers during the runtime protection. So if I open this, you can see that was just a simple bash, right? But ACS was allowing only Java. So anything can be literally anything. It can be a simple cat or a simple ls, right? ACS is going to trigger a violation, is going to queue the pod, and basically reducing the radio blast. But that's processes, right? What about networking? Again, if I go back to risk, Visa, you can also get full visibility on the network part here, right? If you open it up, you see that now I do have a flow from asset cache to my Visa processor, and the ACS is already flagging these anomalies traffic. All right. If I go to flow, you see ACS is here, asset cache is here, flagged as a anomalies flow. Okay. So, which is not part of the baseline. That's why we got a violation, right? So sometimes you are not able to create any network policies at first. Then you can also enable ACS to alert this type of deviation, okay? But let's just close this, at once. So one thing you can do, right? You can always expand the view, right? I'm gonna get here front end and back end. And ACS is telling me that I don't have network policies at all, right? So the icon here tells that all traffic is allowed, okay? So a simple way of fixing that is just clicking here at the top at the network policy generator, right? The middle, generate and simulate network policies, and it should be as simple as that, right? So basically using ACS to learn how the application should behave when it comes to network flows, right? So you can basically download these YAML files, right, which you can basically share with the application owners, or you can store these, I would say, on your Git repository, right? Someone's going to raise a PR, someone's going to review it, which you can leverage this later on to promote to production using Argo CD, all right? So, yeah, so with that, I finished my demo. Natagi, back to you.
Wow, that was an amazing demo. Congrats and thank you, Rodrigo. We see so many advanced feature, advanced cluster security for Kubernetes, and how it can be used to mitigate and prevent vulnerability and build and deploy at runtime phase, and also how we can observe network traffic and how we can, filter traffic, stop traffic, unwanted traffic if we want. So. Thank you all for joining us today. It's been a pleasure to be with you, and I hope you like and you enjoy the session. As a follow-up, we want to give you this pointers. We have two roadshow you might want to try out and like. This the platform engineering roadshow is specific to platform engineering and how you can use DevOps and platform engineering specifically. And we have the OpenShift security roadshow, really focus on security, really focus on the advanced cluster security for Kubernetes. You'll see things that Rodrigo was showing and much more in a full hands-on journey. And we also wanted to connect you with our Red Hat services for application security in case you want to start some business critical project. You want to make sure your setup is fully secure, is fully compliant to regulation and so on. Thank you for joining us. It's been a pleasure, and I hope to see you next time. Bye.